Hey students, this is Mr. Boyd. We're going to start into section 7 today, and we're going to take a look at geometric sequences to begin with. Now, if you remember earlier in the year, we talked about arithmetic sequences, so let's compare those to geometric sequences in this first slide. Just as a reminder, arithmetic sequences, the terms are found by adding or subtracting a common number to each previous term. That number we called a common difference. Those particular types of sequences create a linear function. Geometric sequences, the terms are found by multiplying a common ratio to each previous term. Look at the difference. In one, we're adding or subtracting. In geometric sequences, we're multiplying, and those create an exponential function. Okay, so here's a couple of tables. Notice on the left we have an arithmetic sequence, and each as the n value or the term number increases by 1, the value for the term increased by 4 consistently. Our formula for this table is a of n equals 2 plus 4 times n minus 1. N is the term number, a of n is the value of the nth term. On the right, we have a geometric sequence. Now notice as the term numbers increase by 1, each subsequent term is the product of the previous term times 3. So we multiply 2 times 3 to get 6, and then 6 times 3 to get 18, and then 18 times 3 to get 54. This formula happens to be a sub n equals 2, the initial term, times 3, the amount we're multiplying by each term, times n minus, or to the n minus 1 power. And we're going to look at this a little more in depth here in just a moment. Okay, so here are all the generic formulas for sequences that you need to know for the end of course exam. And you will need to memorize these. These will not be available to you on a reference sheet. Okay? So for explicit formulas, an arithmetic sequence has this particular formula where a sub 1 is the initial term, the first term in the sequence, and d is the common difference. The recursive formula is a sub n and a sub n minus 1 plus d, where d again is the common difference. And for this one, you have to tell, for the recursive formula, you have to tell us both things. What's the first term, and then how do we progress? For geometric sequences, it's a sub 1 times the ratio, because we're multiplying here, n minus 1 power. Again, a sub n is the term number, a sub 1 is the first term, r is the common ratio. All right, let's move on to the next slide. What is a geometric sequence? It's a sequence of numbers in which the ratio remains constant. What is a common ratio? Common ratio is found by dividing each term by its previous term. Now I would encourage you guys to stop and write this down. Go ahead and pause the video and write this down. I will not be pausing during the video for you to do that. So let's take a look at how do you identify a geometric sequence. Determine whether the following represent geometric sequences. If yes, identify the common ratio. So in the first one, if we take 10 divided by 2, we get 5. And if we check that on each subsequent term, 10 times 5 is 50, 50 times 5 is 250, then we could say yes, and the common ratio is 5. Now for this one, we want to do 45 divided by 135, 15 divided by 45, and 5 divided by 15. And when we investigate that, we see that it is also a geometric sequence, and each previous term is being multiplied by 1/3. So 135 times 1/3 would be 45, 45 times 1/3 would be 15, and so on and so forth. How about number 3? So number 3 is 6 times 3 is 18. That looks pretty good. But is 18 times 3 24? It is not, so this is not a geometric sequence. Let's move on to number 4. Now here I notice that we're alternating positives and negatives, so that tells me that my ratio has to be a negative number. And I look and I see 7 times negative 2 is 14. 14 times negative 2 would be 28. 28 times negative 2 would be negative 56. Therefore, yes, this is a geometric sequence, and the common ratio is negative 2. On number 5, we see that, well, this one's a little harder to see, so let's take and do negative 40 divided by 80. And when I simplify that, I see that that would be negative 1/2. And negative 40 times negative 1/2 would be 20, and so on and so forth. So yes, this is a geometric sequence, and the common ratio is negative 1/2. On number 6, all of them are negatives, so I don't have to worry about my ratio being a negative number. What am I multiplying 9 by to get 36? Or what is 36 divided by 9? Well, I see that's 4. And is 144 divided by 36 also 4? And yes, we see that it is, and the ratio happens to be 4. All right, now we're being asked to find the next 3 terms in the sequence. So first of all, we have to decide what our common ratio is, and then we can proceed. So for number 7, it would appear that the common ratio is negative 3, and then if I multiply 63 by negative 3 and keep going, that would be negative 189. Negative 189 times negative 3 would be 567, and negative 1701. I encourage you to pause the video now and try the next one. See how you did. What is 768 divided by 3072 and 192 divided by 768? Well, that common ratio is 1/4. So 1/4 times 192 would give us our next term of 48. And if we multiply 48 by 1/4, we get 12. And then 12 times 1/4 would give us 3. Okay, on number 9, we can see that 4 is 1/2 of 8. So the common ratio would be 1/2. 1/2 of 2 is 1. 1/2 of 1 is 1/2. And 1/2 of 1/2 is 1/4. And for number 10, the common ratio is 5. And the next 3 terms would be negative 625, negative 3125, and negative 15625. Again, let me remind you to pause the video whenever necessary to take your notes. Okay, so now we want to write down these 2 formulas, the recursive formula and the explicit formula for a geometric sequence. So A1 is the first term, and R is the common ratio. So for an explicit formula, A sub n equals A sub 1 times R to the n minus 1 power. That's our explicit formula. Make sure you get that in your notes and labeled properly. Also, you may want to label that n is the term number. Next step. Recursive formula is A sub n equals the ratio times the previous term, A sub n minus 1. Again, this one's only used to find subsequent terms in a sequence as you want to do all of the terms. The explicit formula will take you to a specific term. All right, number 11, and so on. We are being asked to write the rule for the nth term, so we want to write the explicit formula, and then we're being asked to find A sub 7. So here I notice that the first term in the sequence is 3, and the common ratio is 3. So that would make my formula A sub n equals 3 times 3 to the n minus 1 power. Now to find the 7th term, we'll substitute 7 for n in each case. We'll take care of this 7 minus 1. So we've got 3 times 3 to the 6th power. Remember, you want to do your exponents first. So 3 to the 6th power is 729. 3 times 729 is 2,187. This over on the right happens to be the recursive formula for this sequence. Okay, on number 12, we can see that the common ratio is -5. So that would make our formula a sub n equals -4, the first term in the sequence, times -5, our common ratio, to the n minus 1 power. Our recursive formula would be as such: -5 times -4 to n minus 1. All right, moving on. We want to substitute 7 for our n. 7 minus 1 is 6. -5 to the 6th power is 15,625. The last step is to multiply by -4. And a sub 7 is -62,500. Now that's just for the 7th term in this sequence. Look how fast these numbers are growing. We started with -4, and by the 7th term, we're already at -62,000. All right, let's move on to some more examples. Number 13. We start with 400. Second term in the sequence is 200, then 100. Therefore, I can see my common ratio is 1/2 because 200 is 1/2 of 400, 100 is 1/2 of 200, and so on. My formula would be a sub n equals 400 times 1/2, my common ratio, to the n minus 1 power. That gives me, when I substitute 7 into my formula, that would give me 400 times 1/2 to the 6th power. And 1/2 to the 6th power is this big decimal right here, times 400 would leave me with 6.25. Okay, let's move on to number 14. Number 14, we can see that our common ratio is 5 because 5 divided by 1 is 5, 25 divided by 5 is 5, or we can check the other way, 1 times 5 is 5, and 5 times 5 is 25. So our ratio is 5. Here's our explicit formula. And then we'll substitute the term number that we're asked to find, in this case the 7th term, in for our n's. 5 to the 6th power, again, is 15,625 times 1. So the 7th term in this sequence would be 15,625. In number 15, r is 4. We would substitute it into our two values into our formula, then substitute 7. 4 to the 6th power is 4,096 times -1 would give us -4,096. For number 16, we're given a common ratio of -1/3, so here's our formula. -1/3, 7 minus 1 would give us 6, so -1/3 to the 6th power. So -1/3 to the 6th power is 1 over 729. 729 times 1 over 729 is 1. And here are the recursive formulas for numbers 13 through 16. Okay, guys, I hope you will try the remaining 2 problems on your own and see how you do. And then when you're finished, finish it out with a summary of the lesson.